In chapter 14, we're going to be discussing the types of heat that are either produced or absorbed from a chemical reaction. But before we can do that, in chapter 13, we need to discuss just heat in general and how heat is transferred from one substance to another substance. And so the first thing we need to talk about is that there is a difference between heat and temperature. And when you're just talking to your friends, or if you hear people just talking in general, they tend to use the words heat and temperature interchangeably. But in chemistry and science, we can't do that because the two words actually mean two very different things. So heat and temperature are very different, and I actually sent you even another video because I want to make sure that this concept really gets through to you so that you understand the difference between heat and temperature. Temperature is simply a measure of the kinetic energy of the particles of a substance. Now, we've talked before as to how the particles of a substance are always moving. In a gas, the molecules, the particles are moving around at a great rate of speed. They're crashing around, they're banging into each other, they're banging into things. In a liquid, they don't move as quickly, but they are still moving. In a solid, the particles are just vibrating with each other. Hopefully all these things are things that you remember from what we've talked about before. We've also talked about how in something that's hot, the particles are moving much more quickly than in a substance that is cold. If you've ever taken food coloring and put in a hot substance and hot water versus putting it in cold water, you can see that it very much distributes itself far more quickly in the hot water than in the cold water, even if you don't stir it. So that is a very vivid example of how particles move in substances. So temperature just measures how quickly those particles are moving. And the higher the temperature, the more kinetic energy they have, the more the particles are moving around. Now, heat is actually when you have a flow of energy from one object to another object. So if you have a hot object and a cold object, then the heat is going to flow from the hot object to the cold object. If you put an ice cube on a hot burner, the heat energy from the burner is going to flow into the ice cube and cause it to melt. And then it will eventually cause the water that forms to boil away. So heat, when you have that flow of energy, can actually result in one of two things. It can result in a temperature difference, meaning it's going to cause the temperature to change, and eventually the temperature is going to even out between the two things until an equilibrium is reached, or it's going to cause a change in phase. Now, as we'll talk about a little bit later in the chapter, both of these things can happen, but they cannot happen at the same time. But I'm getting ahead of myself. So for right now, just be aware that heat will flow, and it will either cause a change in temperature or it will cause a change in phase, meaning from a solid to liquid, or from a liquid to a gas, or it can also go the other way around as well. Okay, so how do we measure heat? Well, we measure temperature in degrees Celsius. If you happen to live in the United States, we still measure in degrees Fahrenheit, but most other countries are measuring it in degrees Celsius. We talked about Kelvin temperatures, which scientists will use because it's an absolute temperature scale. So all of those temperature scales are used to measure temperature, but how do we measure heat? Well, heat is measured, generally what we're going to be using is either calories or joules. And most of our calculations are going to be done in joules, but because calories are something that is at least a word that most students are familiar with, that's where we're going to start. And you've heard that food has calories in it. So a food calorie isn't the same calorie as the calories that chemists use. A food calorie is actually equivalent to 1,000 chemistry calories, as the author of your book puts it. And how big is a calorie? Well, a calorie raises a gram of water 1 degree Celsius. A gram of water is not very much. And so we're talking about a small amount of heat here. So it's not a whole lot. Let's try to put some put some context with this, you can understand how much a food calorie actually is. So on the problems that I sent to go with the videos, we'll look at the first one. The question was, how many grams of water can you raise 1 degree Celsius with the energy from a chocolate ice cream cone, which has 310 calories? And that's 310 food calories. And normally we're going to delineate between the two. If we're talking about a food calorie, we're going to use a capital C. So 310 calories is the calories in a chocolate ice cream cone. Now that, of course, is going to depend on how big a scoop you put on your chocolate ice cream cone, but just to give you a general idea. So 310 food calories is going to be how many of these kinds of calories, of the chemistry calories? Well, if there's 1 food calorie for every 1,000 chemistry calories, that just means I need to take my food calories and I need to multiply by 1,000. So 310 food calories is going to be equivalent to 310,000 chemistry calories. Okay? Now, for each chemistry calorie, it's going to raise 1 gram of water by 1 degree Celsius. So therefore, that means 310,000 calories can raise 310,000 grams of water by 1 degree Celsius. Okay? Again, that's something that's kind of hard to wrap your head around. So part B of this question is going to help us try to quantify this a little bit. So part B of the question says, from the same ice cream cone, how many degrees can you warm 10 liters of water? Okay, now 10 liters of water we can kind of wrap our head around, because a liter of water, you probably have bought beverages in liter containers. Soda pop tends to be sold in 2-liter containers here in the States. And again, depending on where you live, you probably have liter bottles, half-liter bottles, 2-liter bottles, and so you probably have some sort of a picture in your mind how much 10 liters would be. Okay, so 10 liters is going to be the same thing as 10,000 milliliters, because remember there's 1,000 milliliters in every liter. Well, 10,000 milliliters is going to weigh 10,000 grams, because if you remember from way back in the first chapter, we talked about the density of water, and we said the density of water is 1 gram per milliliter. Milliliter, you've seen in your graduated cylinder, a milliliter is not very big. And so 10,000 milliliters of water would weigh 10,000 grams. Well, I have 310,000 calories to use up. And so if I then take 310,000 calories and I divide that by 10,000 grams, then what that's going to give me is that I'm going to have 31 calories for every gram of water that I have. And so that means that that's going to raise the temperature by 31 degrees Celsius. So to just kind of sum everything up here, if you have 5 2-liter bottles of pop, and you use up all the pop, and then you fill those bottles with water, the energy in 1 chocolate ice cream cone could raise that amount of water by 31 degrees Celsius. Okay, so hopefully that gives you some sort of a picture just how big a calorie is and how much water it can heat. You will be doing some problems like this in your assignment for today. So hopefully that will give you an idea how to go about doing those.